Oh, what a day! What a lovely day!
Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you're new to this channel, or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside each of these shows while they're live, and there's a link in the info box below the video once it's rendered. Most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the discussion and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected. And if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show. Sharing the show increases the live audience, of course, but this in turn increases the chances of a more diverse panel. So please share the show. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now, we are joined by Angel, Arwin, John, who else we got? Nummy, Sleeping Warrior, and Mark. How are you all doing?
All is good, and it feels like we should be having a nice little circle jerk today. But that means I don't have to move from the sofa, and I don't have to watch the back door.
Doing well.
Maybe. We'll see how it goes.
Yeah, let's bust up some globes.
Hello, gentlemen.
Hey, Mark.
I don't know too long, but I just thought I'd come in for a little bit since I have a few more minutes to kill.
Good stuff.
Yeah.
We got sound from Angel. Can you hear us, Angel?
Yeah, I'm good.
Excellent. What about Arwin? How are you, Arwin?
Yeah, doing great.
Big shoes to fill today. Globebusters aren't broadcasting. We're taking their time slot, along with probably a dozen other YouTubers. Now Ranty's tipped them all off.
Yeah.
Yeah, I noticed IPS was doing a Globebusters fill-in episode.
There you go. They've all had the same idea.
We're trying to
Lots of
snatch their audience
variety.
away.
Lots of variety. If you're tuning in now and you're expecting Globebusters, worry not. You will be entertained.
Well, that was a great show earlier today.
It was. I missed it, and I was listening to it like about an hour ago when I got sidetracked and ended up in a Skype call. But the moon seems to be a hot topic at the minute. I really want somebody to produce evidence that proves that the moon has 3 dimensions to it, depth being the other element, because we see it as a flat disk that illuminates like a flat disk, and it doesn't illuminate like a ball. Where's the evidence that the moon is anything other than flat?
I have a problem. I have a problem with that, Anthony.
I don't care what problem you've got. Have you got evidence?
Well, okay. This is personal experience. If you have a dinner plate, if you're looking at it side on, no, directly on, it's a circle. But if you start to move it in any direction, it becomes an ellipse. The moon is always a circle. No matter where it is in the sky, it's a circle.
No, it's not.
Okay.
The moon is often half crescented.
Oh yeah. Listen, you know what I mean.
Yeah.
If it's a full moon, you get a full moon for probably 2 or 3 days, and no matter where it is in the sky, it's always a circle. It's never an ellipse. And yet,
let me ask you this:
go on.
See the moon rise and set like the sun. We see it rise in the east. We see it set in the west, and we call that 180 degrees. Is it really 180 degrees, or are we seeing a smaller section of the sky than what we think we're seeing? The reason why I ask that is, if refraction can bend light so badly, then maybe we're only seeing a small section of the night sky, and this atmosphere that we're under, that we do live under, we do have an plane or an atmosphere. Maybe the atmosphere is making us see things that differently to how they actually are. And the reason why I say that is because when you go to the high altitude balloon footage, the sun and the moon look like pinpricks in the night sky. They're not the size that we see them on the ground.
Yeah, the moon tends to get very small.
Yeah, they're very small, but you're getting closer to them in theory. So you would expect them to be at least be the same size, but not shrink. So perhaps the atmosphere is making us see things, not just the sun and the moon being bigger, but maybe we're not seeing a whole 180 degrees of the sky, but we think we are because of the atmosphere that we're under.
Well, there may be some kind of.
It's not enough just to think what we see. Is it really? We're asking people to be logical. It's not what I think I see.
Nah.
No, but there are some elements. If you're gonna see certain aspects, then that will exclude other things. So, if
Well,
there are strange anomalies, like the moon growing smaller all of a sudden, or just rapidly changing position when you go up, then that gives a hint that it's not a physical object that is in a specific type of orbit. Whether, yeah, of course, it's not spinning around the globe Earth, but not over a specific circle either. So, it's just
if I lived on the equator or the ecliptic, I would see the moon rise in the east and set in the west as one complete circle all the time. But I'm not on the equator. I'm a few degrees north, and yet I see that the moon as a complete circle for about 24 hours in the month when it's a full moon. Whatever it is in the sky, it's a full circle. It's never elliptical.
That's not true though. When the sun and the moon are setting or rising, they're not presenting themselves to us the way that they actually are. Forget about the magnification point, but when you see the sun setting, for example, how many times have you seen the sun setting and it goes like it ripples like water, like
No, we're not talking about this. We're not talking about the sun here, Andy. We're talking about the moon. Now, at the moment, the moon is waning, but in about 13 days, it'll be full moon. So you and I have got our cameras. We can go out and take photographs of the moon over a period of time, and it never appears as an ellipse. It's always circular. And you and I are in a very similar, what do you call it, longitudinal?
Latitude.
Sorry, latitudinal line. So if you can, I think you know what I mean. You know what I'm saying. My personal experience is that whenever a circle is slightly at an angle to me, it becomes an ellipse.
but that's only if you take it as a physical circle object, like a literal physical disc. Of course,
yeah, that's what I'm going
if you're
by.
looking from sideways, you're just looking at a line basically. But
yeah, but the thing is, when you see the sunrise and the sunset, we don't see the moon change. We're not looking around the other side of the moon because it's sunrise and sunset, or moonrise and moonset. So what you're saying on the one hand makes logical and reasonable sense, but you would also therefore accept logically that we would see 90 degrees of the moon that we don't see when it's at high moon point. I was going to
But
say,
at the moment, I'm looking at the moon, and it's waning at the moment, and the moon suddenly appears after the sun sets. The moon suddenly appears because the night sky goes dark. So about 10 o'clock tonight, if you look up in the sky, you'll see a waning moon appear.
But Mark, I think you have to look at your all the underlying assumptions, right? Like Arwen's trying to point out, and it's very valid, that we don't know whether the moon is a solid physical object, right? So I don't think anyone here is trying to say that there's no way that the moon could be a sphere, right? It's just that we're just acknowledging the limitations of what we can really know about it for sure, right? So
yes,
I
accept that. What I have dismissed is that the moon is a disk.
Yeah, but I don't
fine.
Air disc.
Okay, that's fine.
Seems to be like it is being reflected. That is the most primary aspect about it. It just seems like it is a reflection of something.
It
Somehow
may be,
being mirrored.
but I need more than just. It may be a reflection. I'm just going by what I personally experience.
Yeah, but let me ask you this, right? Somebody was asking about craters that on the moon that
Yes.
were not there 10 years ago, but now are. And apparently there's the odd one or two, but they're really wishy-washy. I asked Nathan offline, would it not make sense that we could challenge NASA to create a crater on the moon? Like send a missile up there, let it explode, see the crater that was created, because it can't be unobtainable, right? It must be possible if it's what they tell us it is. And Nathan said, yeah, but what happens if it's not what they tell us it is? And then we're fucking around with balance of nature. And that's a fair point. But surely, aren't we better off challenging the NASA boys to create...
You know that they actually did...
Knowing that they can't do it.
You know that they actually did claim to do that, but it was like apparently right at the pole, so that we wouldn't see the crater because it would be like right on the side.
So they didn't do it at the pole.
Nominum
They
and
didn't
Antony.
do it at the pole.
We know that
Wasn't it
NASA
pole?
are liars, so we can't bring those into what we're discussing at the moment.
Was it not at the pole? Where was it?
Sorry.
There was an area of debate that they felt that there were structures around one of the craters, and they thought that there was a city by the way that it looked. And that happened to be the one spot that NASA miraculously decided to launch a nuclear bomb, and they wanted to do it to ping it like, you would a bell, and listen to it vibrate so they could tell whether or not there was water. I don't believe they ever published the results, but they did hypothetically do that on, I think it was September 10th, like 2012-ish.
Yeah.
It wasn't a nuclear bomb, though, was it? Wasn't it like
They said it was a nuclear bomb.
Did they? Okay, sorry, I could be mistaken. I'm not clear. My memory on the event isn't perfectly
Wait,
clear.
are we talking about the moon?
I don't think
Yeah.
I wasn't. I don't
That's
remember it being.
insane.
I don't remember it being a nuclear bomb. I thought it was like that. It was basically like a defunct orbiter or something like that. I don't know. I can't remember the details. You could be right.
Well, the intention, their whole premise was they wanted to like hit it like you would with a ball peen hammer on the side of a bell, and listen to it ring,
That
and
is
then from
just
that
crazy.
they could tell whether the frequencies that it regurgitated back, just like we do when we're looking for oil and stuff underground, and we do the ground penetrating radar, to sense whether or not there was water on the moon. That was the premise behind it. They picked, I believe it was Hoagland or something like that, that was focusing on one particular area where it looked like roads and like how everything was graphed out, like it looked like a planned community city. And they
You mean
decided
the glass? You mean the glass tubes and everything? I was
Yeah,
into that for a while. That is very fascinating stuff. But
there
it's
was,
obviously fake.
well, it may have been fake, but whatever the reason, NASA decided to use that particular area as their 0 point for where they say they detonated a nuclear bomb. So hypothetically, if it was a civilization, A, we've pissed them off, and B, if it is just a image that we're looking out in space, they shut people up by saying they bombed it. It's
Okay,
all.
I found the article here, and if this is correct, it wasn't a nuclear bomb, but it was in fact an orbiter.
It was in fact, or is that an
Thank
opinion?
God.
Well, I'm in fact of what NASA said. Not
Listen,
Right.
forget NASA. Why are we referring to NASA? We know they're liars.
well, because we're talking about their narrative. I mean, I'm not.
Yeah,
I'm
This is
saying.
if
true.
I
We-
was a Glober and I heard that they would actually nuke the moon, I would go ballistic. It's like, are you totally out of your mind? You're gonna
Some people
you're gonna
did go.
knock the moon out of its orbit or something. It could be extremely
Uh,
dangerous.
if I were a Glober, I'd be saying, yeah, come on, we can create a crater and prove that the moon's a tangible object.
With the
man. Let's
nuke,
do it.
are you serious?
Yeah, I
That's
bet
crazy.
I would definitely push that.
That's crazy, man.
It's only a nuclear bomb on the moon that nobody lives on, right?
This conversation began with you suggesting that, and I'm saying, and then I was just saying, well, I think that they've already claimed to have done it, right? I mean, I'm certainly not suggesting that they did anything of the sort in reality.
Right, guys,
They have claimed to have done it.
Well,
Just
maybe
to let-
it was a regular bomb.
just to let you guys know, Dave Marsh has had the link, so if he joins, don't kick him.
I think the link that I put in there is actually describing it. Moon smash gives off flash. For many astronomers, NASA's frontal assault on the moon ended in a fizzle on Friday. The Lunar Crater Remote Observation and Sensing Satellite crashed near the lunar south pole as planned, but an expected plume of bright debris was nowhere to be seen. That's the event, isn't it? However, mission scientists said that they did spy a thermal flash and spotted a crater, perhaps 20 meters wide, created by the impact. So they created a small crater, but unfortunately it was right at the South Pole.
Yeah, how convenient.
Yeah, how convenient. Because what they're saying is that on the poles where there's the least amount of light, that there's frozen water there, because otherwise the water would evaporate when it was exposed to the sun, right? So they're saying that, well, they had to do it at the pole because that was what the whole point of the test was to see if they could melt some of the water that was supposedly there.
Yeah,
I mean, this is all just a bunch of fairy tales anyways, but I'm just saying.
It's an invalid piece of evidence, right? It doesn't address the point in hand.
Well,
We
no,
did something, but you can't see it.
Yeah,
Suggesting that they would create I guess it would have to be a creator.
just another story.
Yeah,
Hi,
of course,
Dave.
it's just another story. I'm just saying that, like, it's interesting that they've already kind of they're
Hey,
a bit
Dave.
ahead of.
Well, I appreciate the research.
Pardon me?
I appreciate the research. It's appreciated.
Mhm.
Well, it's funny. I think I don't know, but yeah, I mean, it would have been. I think we should challenge them to create a visible crater, right? I'm sure they've got a whole bunch of. There must be some other junked orbiters.
Yeah, but they're now they have their story, so they are going to say, yeah, but we already did that.
Yeah, and then they can look at it with another one of their fake orbiters.
So now we've got Dave in the chat. So basically, Dave's quite interested in the moon. He's done quite a lot of research on the moon.
How you doing, guys? You okay? Can you hear me all right?
But suffice it to say, they didn't claim to nuke the moon, right? They were just crashing some of their space junk into it, supposedly.
What
Yeah,
do you have
fine,
to
Dave,
contribute,
just so you know.
Dave?
Well, I was just listening to the conversation, and I can't really comment a lot about what you're talking about, but what I can do is disprove the actual elliptical orbit of the moon by proving that the moon speeds up going to and from apogee, which from a globe perspective, it should only speed up as it's heading towards apogee.
Ooh.
So I've got documented evidence backed up by the meridian passing readings from time and date to prove this. And if anybody can disprove it, I'll be happy to see it.
So what you're saying is that apogee going towards and from apogee, it speeds up, but on the heliocentric model, it only does it on the approach to apogee.
On the globe model, it should speed up as it goes to perigee, but from a globe perspective, yeah, it would only speed up as it goes towards apogee, if you can understand what I mean. It's quite difficult to get your head around it. Although if you looked at it from like a bird's eye view from ahead, yeah, it would speed up as it's supposed to get to its closest point to Earth. But from a globe perspective, that speed up would be observable at apogee.
Yeah, I saw Chris Monk make a CGI model of the moon following this path, and yeah, he demonstrated it. Yeah, look, this is how it's supposed to look, and you see the moon like going smaller,
Yeah.
going smaller. Like, okay, we definitely do not see that.
I think the Morgile did some interesting work on this subject as well at some point. I can't remember what the video was, but he talked about this as well. So I know what you're talking about. I can certainly.
Right, so Dave, I think you need to explain the two terms, perigee and apogee, right?
Yeah, well, perigee is the point where the moon's at the closest point to the Earth, so it should, in theory, appear bigger in the sky, and apogee is the furthest point in the cycle where it should appear smaller.
So,
But
Dave, when it's
according to the heliocentric principle, right?
Yes, according to the heliocentric model.
Dave, when the moon is on the outside of the Earth from the sun, it has to travel a lot faster to get across the arc than when it's on the inside of the Earth to the sun. Is that what you're coming from?
No, because basically the sun doesn't have.
I reject the heliocentric model. It just doesn't work.
Yeah, it's impossible, and also because the Earth's in motion and the sun's in motion, it's impossible to create an elliptical orbit from two foci or two focus points. It's impossible.
Unless gravity is smart and it can work it all out itself.
Exactly. For starters, you need two focus points. Yeah, yes. You've already got sun in one focus of the ellipse, and you've only got the Earth in one focus of the ellipse of the moon. So straight away, the ellipse wouldn't work anyway. You'd get concentric circles.
Yes, absolutely. So, yeah, that's where I have worked out and dismissed the heliocentric system.
Yeah, and that's not even taking into account the galactic orbit and all of the momentum, all of it. It's totally like the moon catching up and everything has to catch up when it's in the.
We're all blasting to a northern constellation somewhere towards Lice. So.
Yeah, but it looks really nice in CGI though.
It looks beautiful, doesn't it?
Dave, what's your view on the epic, the epic footage with the
Discover R, epic satellite from 1 million miles away?
Yeah.
It's the worst looking CGI I've ever seen in my life.
And there are ballers that have to accept this. All ballers have to accept that this is truth, right? And they must cringe when they're asked, "Do you accept that evidence as truth?"
Yeah,
You know,
I've actually got it. I've actually got it as the last slide in my presentation to say well, this is not what the moon isn't, kind of thing.
Oh, I reckon we should let Dave make a presentation and give him the mic for a bit. Let's not debate him. Let's make the point, and then when he's finished, then we can hand back to us. Do you want to make the presentation, Dave?
Do you want me to do like a really quick version from my observations? I won't go into all the. I'll just start from like the Kepler's law if you want. So it's up to you.
Take your time.
What would the estimated time be for both?
I could probably do it in an hour.
Is that the short version or the long?
I'd say the short version. Probably be about an hour and 20 minutes, an hour and a half. If I did the full version.
An hour. That's a long time. What do you reckon? Yeah. Is an hour good?
Yeah, I'm good with that. If everyone else on the panel's happy with that.
I'll sit back and I'll enjoy the moment.
Long weekend.
I've seen this before on Sun and Moon Group before, and it was brilliant. So if you just get the popcorn out and sit back and watch this is brilliant stuff. So over to you.
I'm just gonna duck out. I gotta go pretty soon. So nice talking to you, however briefly, and have a good time.
Cool. See you later, dude.
Yeah.
All right. I'm gonna watch in the back.
Okay, let me just get some windows open here before I do, because.
Yeah, no worries. Just let us know when you're ready and I'll present you.
Yeah, okay. I've actually done some more work, and I'm adding to this all the time. Like I've actually got some comparison charts now from different areas in graph form. So I'm always like adding to it as I go along. So right, that's one window. Two more seconds and I'm ready.
Take your time, dude.
Yeah, I've just got to get it all ready, like, because I've just only opened the computer up. I'm just trying to get everything there. I would prefer it if I could actually share the screen and not the actual app, if that's okay. And I'll cover the actual link up with the actual screen. Is that all right?
Yeah, that's fine. Just let me know when you're ready. I'll put you up.
Yep.
I'll probably open up the link later anyway, so even if it did get displayed, I probably wouldn't be that fussed. It's not like it's set up not to have that happen, so don't worry.
Yeah, like I say, it's... Right, I'm ready.
Okie doke. Over to you, Dave.
Right, I'm not going to go on about introductions. I'm sure the majority of people in this hangout know me, but if you don't, my name's David Marsh. I've been a flat earther for probably 2.5 years. I think it was around about November 2015 when I first stepped across flat Earth, and I started doing my own research. About 6 months after that, I bought myself a camera and started observing the moon, doing various moon sinks and tracking the moon. I had a few debates with Darren Nesbitt in regards to the shape of the flat Earth, whether it's a disc, a square, or this, that, and the other. So that's how I actually derived the experiment moon race, basically, because at the time of thinking, I thought, well, if I record the speed of the moon and I can prove that it's speeding up as it gets southern declination to its furthest point on the Tropic of Capricorn, I could disprove Darren Nesbitt wrong and win the debate. But what I did find that the moon actually slowed down when it went onto the Tropic of Capricorn, which I thought was really strange at the time. But I have a little bit more understanding of that now. So basically, majority of us here know that the Earth's flat here, and no matter how high you are, the horizon is always at your eye level. Even
Ooh,
at,
I'm not sure
even
about
at
that one.
121,000 feet, you've still got the horizon at the eye level, which
I'm
I
not-
call the
not-
horizontal eye zone.
I'm not sure
So-
about that, if I'm honest. It's not always at eye level, is it? Well, it depends what you mean by eye level, but it's
Yeah,
not
it's
horizontal.
it's what I call eye level anyway. Like I say, it rises with you regardless of the height. So
Sure.
So what I did here, I just basically went onto Google and I typed in images of Earth, and I took a snapshot of the screen, and that is the screen that I got after the snapshot. Now the top ones are all supposed to be real images of Earth. Now, first thing I noticed, not one, two image of Earth looks alike. Like I said, there is a few images a bit further down there, what are obviously graphics. You can see that one there, what's a bit oval shaped. I'm sure that's not supposed to be a real picture of Earth, but the top ones are all supposed to be images of Earth. Now, if you can find me a real image of Earth, I'll be happy to see it. And you can throw the 1972 Apollo images towards me, and I'm not even going to accept them because no two images look alike. I mean, if you look at the second image, look at the side of America on that one. It covers off the globe. So, and you'll probably be aware of this guy, Rob Simon, the guy who actually creates the Earth for NASA. He has been quoted in saying basically he takes a flat
Because it
map,
has to.
yeah,
Photoshop because it has to be.
and he wraps it around the globe. Rob Simon, aka Mr. Blue Marble, yes, and it's Photoshop because it has to be. So, what we're told then? So we're told that we live on a globe, yeah, and we're orbited by a single satellite, which we call the moon. The moon cycle, it takes 27.3 days to complete its orbit. But interestingly, the phases take slightly longer at 29.5 days. The reason for this is because the cycle is related to the sidereal day, which is 23 hours, 56 minutes. That's for the star to occupy the same spot the following night. And the phases are related to the sinusoidal day or the solar day, which we all know is 24 hours. There is a number of different cycles in there. I can't remember them off the back of my head, but you've got a cycle from perigee to perigee, which is 27.5 days. Then you've got another cycle which is 29.3 days. There's about 6 or 7 different kind of cycles for the moon. It's strange. There's not just one cycle for the moon. So if you do look into it, you'll see there's a number of different cycles which really don't make a lot of sense. But I'm just going to stop it here. Now, if you look at that little globe in the corner there, what you will notice is that moon there is in the path of light. Now, I'm sure many of you have seen a crescent moon at night time. What I would like to know is one day after a new moon, when you can just see a little smidgen of a crescent moon, how the hell can you see that at night time when it should be in the path of the sun? It should be impossible. But night after night after night, just after new moon, or as it's just coming to new moon, you'll see a crescent moon at night time.
So, just a quick interruption, and I promise I won't do it again. Do you
No,
agree
you're okay.
we should never get a full moon? We should never see an illuminated side to the moon.
Well, interestingly, you only see a few moon for actual few seconds anyway. You know, an actual proper full moon, because it's either waxing or waning. You only actually have a full moon for a few seconds. But in regards to should I see a few moon? To be honest, I'm not 100% sure. If I'm honest.
Okay.
I couldn't really answer that question. Like I say, I learn as I go, and you know what I mean. I just pick up things as I go along, and but I couldn't really answer that question.
No worries. As you were, my friend. As you were.
Dave, that's where I am at the moment. I'm watching the moon, and it seems to be waning at the moment.
No, it's waxing at the moment.
It's waxing, okay. And just as the sun goes down, the moon appears. It's not as though the moon was there earlier on in the day. It just suddenly appears.
I've seen it all day today. I've seen it from 12 o'clock today.
Mm.
I've been filming it. I've got it on my camera now. I've
Oh,
just
brilliant! That's fine. That's great.
yeah.
'Cause I-
You just got it's really really high in the sky because it's on the Tropic of Cancer. So so it's nearly as high as the sun. What you'll find is where the sun when it's high on the Tropic of Cancer,
yeah.
it'll be really really high in the sky, but the moon falls short of about 5 degrees.
Okay.
Because
The sun disappears about 10 o'clock at the moment, and then I notice the moon, and it's quite a thin slither.
yeah, really high in the sky. Yeah.
Yeah.
It's out all day, mate. I've seen it since about dinner time today. Yeah, I've
Okay.
been showing a few neighbours the moon like in the daytime. So yes, it's definitely out through the
Good
day.
man. Oh, carry on. Sorry to disturb you.
Yeah, I'll move on because, like I say, it's quite a long presentation.
Although he chose to listen first, Kepler only came to this
Have we lost your sound, Dave?
We've lost something there, gentlemen.
I don't know if something's gone wrong with Dave's sound, but we can't hear you anymore.
This looked really interesting. But
Oh no, Dave!
No, this is the good bit with the second pivot point with regards to Kepler's law and orbital motions in a
This is the good bit, and he's
ellipse. Sorry, good evening, guys.
Hey,
Hola.
hey Adam. Good to have you.
All right, guys.
Adam from Iron Realm Media. Give your channel a plug. I really enjoyed Friday's show.
Oh, it was a cracker, weren't it?
It was excellent. All about gyroscopes. Fantastic.
You ever see, like, it's very, I'm struggling, honestly, to have a point where all of us were in awe of the guest. That all of us were just, we've had people from loads of different fields, mate, but every single one of us was like, this guy just rocks, doesn't he? And to not have had him out there before, we were pleased with the coup, mate, but you know what I mean? It was just fantastic to sit and chat with him, and we've been lucky enough prior to the show to have a bit of heads up, but it was, I really loved Friday night, mate. Thanks. I'm glad you did.
Yeah, I stayed till about 1 a.m. listening to Rob and you guys chatting. It was brilliant.
I gave you a spanner.
Yeah, I noticed. Thank you very much. Not that I ever use them, but it's nice to know that I can't get timed out by somebody if I say something I shouldn't.
I'm back. Did you hear that? Because what I had to do basically, I had to put my microphone inside the ear of the actual headset. It's the only way I can play it. There's no sound otherwise. I'm sorry, but
We didn't hear any of that.
Didn't you?
Yeah, it's gonna have to be audio from you only, unfortunately.
Yeah, no problem. That was the only one I wanted you to listen to. It actually worked when I did it on the Sun and Moon group because I had the volume a little bit higher in my ears, like so. You could hear it. So I fed the microphone into the earpiece and it fed it back that way. But anyway, basically Kepler's law states that the moon should speed up at its closest point and slow down at its furthest point. A couple of things, like I mentioned earlier on about that second focus point or foci, it's non-existent. So the ellipse would be broke anyway because there's no second focus point. And every time you look online and you try and find out about this second focus point, it's always that the sun is in one focus of the ellipse or the earth is in one focus of the ellipse. You never hear anything about the second one and they never mention it. But interestingly, after Kepler's law, William Herschel, who was another astronomer, he's responsible for putting the actual solar system into motion. Yeah. So when you're thinking about an ellipse, then also you've got the sun in motion, then that just completely destroys the ellipse. And one other thing you have to keep in mind is that Kepler's law was built on the back of observations that he obtained from his predecessor or his rival, some say, Tycho Brahe. Now, all his observations of Mars were recorded before the telescope was even invented. So it's not really a good building blocks for Kepler's law in my mind. So anyway, we'll move on because I think we're getting near. Oh yeah, today's scientists have substituted mathematics for experiments, and they wander off through equation after equation, and eventually build a structure which has no relation to reality. Now that quote, I love that quote because it's so true. because there is no experiment these days. It's all numbers and figures.
Amen.
Yeah, and when you're debating people, you're just debating numbers and figures. They're not showing you any real proof these days, are they? You have to take their word for it and
Praise maths. Praise maths.
take their numbers for it.
Yep.
I need my phone for this bit. Just give me 2 seconds. I'll go and get the actual book because I need a section out of a book.
Good old Neil deGrasse Tyson.
You gotta look at that bio.
I'm actually taking this book out of the packet. And it's only been out once before ever.
While we're filling here, Dev, I'll say good evening, mate. It's Adam.
Oh, how you doing, Adam? You're right. I thought I heard your voice when I was trying to feed that earpiece, that mouthpiece through the earpiece.
Yeah, not bad, mate. Are you?
Yeah, I'm good, mate. I'm good. Yeah.
I saw you was on, and I do love this. And I'm less hungover now than I was when you were presenting it
Cool.
a few weeks ago. So I thought I'd jump in and just listen through this, bro. So yeah, enjoying it so far, mate.
Right. So Neil deGrasse Tyson, I'm sure you've heard his famous words when he's talking about the Earth being oblate, but it's not quite oblate. It's actually chubbier below the equator. Basically, it turned around and said that the Earth is pear-shaped. Now, I've just opened up Static Astronomy from 1904, and I'm going to just read a little section from page 14. It says, theory, first of all, makes the Earth to be a globe. Then not a perfect globe, but an oblate spheroid, flattened at the poles. Then more oblate until it was in danger of becoming so flattened that it was like a cheese. And passing over minor variations of form, we are finally told that the Earth is pear-shaped and that the ellipsoid has been replaced by an apoid. What shape it may assume next, we cannot tell. It will depend upon the whim or fancy of some astute and speculating scientist. That's from 1904. So next they'll be telling us the Earth's shaped like a shiitake mushroom, and we'll have to believe it because they've said it. Has somebody got some feedback going on?
Oh, it's probably me. Sorry, Dave.
So my observations. As you can see here, what I've just done, yes, I am using an app from a phone and a camera to make all my observations. What I just wanted to show here that is the app I'm using is quite accurate. I've basically laid a compass down here and I've just took a snapshot of the actual compass to show that the app is pretty accurate. Basically point the compass at north and took a picture and you can see. So all the observations I made were from my old house in Ripley.
Can I just say as well, don't we have a declination adjustment of 1 degree?
What I did, I just left it, mate. 1 degree to me for what I'm doing is, if you've ever held one of their maps up towards the moon and tried to take a snapshot, mate, it's...
No, what I'm saying is the compass is showing almost north at 360 or 0, but it looks like it's off by 1 degree. And what I'm saying is the declination adjustment for the UK is 1 degree.
It's probably why it is off then, mate, because I didn't adjust the declination for it. I have played about with that declination in the app, but I just left it at 0, mate. It's a lot easier for me just to work that way, because when I did set it for 1, I was about 4 or 5 degrees out when I kept aiming it, so I just left it at 0 in the actual settings in the app. And like I say, it's accurate for what I want to do. 1 or 2 degrees. I'm just trying to basically say that the moon is in that spot, relative to where it is on the moon calc or time and date, say. But yeah, like I say, it's accurate enough for what I were doing. So all my observations were shot using the Nikon Coolpix B700. I don't really like the P900 because it's too big, and it's got quite a few extra features on the B700 because it come out a few months after. So I shot all my observations from the same location, at the same zoom length, and at the same frame rate. I always shot it at 1080, 60 frames a second. So I kept all my observations all the same kind of thing. Consistent, I was looking for the word. So this is just a little comparison of how myself compares my observations compared to somebody who does their observations based on a globe. Now, I'm sure many of you who've started researching flat Earth have looked into the law of perspective, and we do know that when an object is closer to us, it will appear higher, or when it's further away, it will appear lower. That's how I've been judging my observations with the moon. When the moon is high on the Tropic of Cancer, I say that that's closer to me. When it's further away on the horizon, I say it's further away. From a globe perspective, that's slightly different, because when the moon's high on the Tropic of Cancer or low on the Tropic of Capricorn, it's nothing to do with it being close or far. It could be at perigee and still be high on the Tropic of Cancer in their model. It's the reason why it appears high is that 5-degree inclination. Now that's similar to the Earth's 23.4 degree tilt in regards to the sun. It's the same in the globe model for the moon. As you can see, that 5-degree inclination there. Interestingly, I was mentioning before that the moon falls short of the tropics by about 5 degrees. So whereas the sun deviates at 23.4 degrees from the equator, the moon only deviates about 18.5 degrees. That's where that 5-degree inclination comes in for it, because it falls that 5 degrees short in the globe model. So that's where they've actually got that 5 degree from. And this is a picture I took from some of you might recognize it from the hotel in Birmingham. I come into the corridor. I thought, oh, that'll make a good picture for demonstrating the law of perspective. So I took a picture there, and as you can see, the lights which are closer to me appear higher, and the lights which are further away appear setting. And no, them lights aren't setting over the curvature of the carpet.
It's not just that, Dave. It's the way the carpet raises up. If you go back, it's a really good photo of that, mate. The carpet raises above. Look at that. That's fantastic.
And it's just like Soundly's Pontchartrain stuff.
It's just, I can see the curve.
The curve of the carpet. Maybe the hotel's curved. So moving on to my first observation, I think it was on the 3rd of March, 2017. I waited till the moon was on or around the Tropic of Cancer. I'd just like to thank Jenna Fredo for this time-lapse video. I got permission off her so I could use it. So my first observation on the 6th of March 2017. As you can see, I took a snapshot of the moon. It's a waxing gibbous. I also took a snapshot from NASA's Lunar Reconnaissance Orbital platform. This is basically their model of the actual moon, taken from all their information they collect from the satellite, what apparently orbits the moon. And as you can see, the moon here is heading towards apogee. It's actually at perigee. What you'll find in the globe Earth model as well, sometimes the moon will reach 28 Earths away from the moon, and sometimes it'll reach 32 Earths away from the moon, and sometimes it falls a little bit shorter either side. But the interesting thing here is that the moon is relatively at perigee, so we'll keep an eye on that. And as you can see, the phase is basically exactly the same. I couldn't get the time absolutely perfect, but it's round about there. I also took a snapshot with an app called Dioptra, which you can get off Android. They have a similar app on iOS. I think it's called Theodolite, if I'm correct. And what you'll see, when I make my observations as well, I should have said this earlier on. I always try to catch the moon at my zenith, which is always 180 degrees south. So that's why I always wanted to catch it there, to be consistent through all my observations. Because I thought if I catch the moon when it's rising, it may rise a little bit faster, or it may set a little bit faster. Because I know that in places like South Africa, the moon does rise and set really, really fast. Well, it appears to. So I thought I'd catch mine at zenith, 180 degrees. As you can see there, my reading azimuth was 187 degrees south, and my declination angle, which is there, is 56.1 degrees, which is fairly high in the sky. You have to break your neck to see the moon when it's that high. What I did then, I went on to Moon Calc, and I actually see if my readings were matching up with what their readings were saying. As you can see there, the moon horizontal angle, they call it, is 183 degrees, and the moon elevation angle is 55. We'll just click back to mine. Mine was 187 and 56. What I found is as well, calibrating the gyros inside a smartphone is not an easy task. You may think that you just rock it up and down or backwards and forwards, but basically you got to swing it around like a madman. You know what I mean? I was in the garden making figure eights, doing backflips, doing all sorts to try and get it level, because I knew it weren't accurate sometimes, because I pointed there and it was about 20 degrees out. So you have to really try and swing them around to get them accurate. So a week later, when the moon's over the equator, not many people know this, but the moon actually crosses the equator 26 times a year, compared to the sun, which only obviously crosses it twice in a year. The moon actually crosses it 26 times. I'm just going to click back onto that one. What you will notice as well, the moon travels in a fairly straight line when it's on the equator. When I'm talking about the equator, I'm talking about the celestial equator. Yeah, not the geographical or the invisible line on the globe. I'm talking about celestial, not terrestrial. There you can see nearly a full moon on the 13th of March 2017. And there you'll see the comparison to NASA's moon phases. Now you'll see that the moon is actually moving away towards apogee. So in their model now, what we should see from an observer's perspective, you should see the moon speeding up. Because remember, when the globe's spinning and the moon is actually going a slower point in its cycle, it will appear to speed up. It's quite difficult to get your head around this, but I have run this past Chris Monk-Seeley, and he confirmed to me that is the actual fact. From a globe perspective, it would appear to speed up at apogee and not perigee. It would actually retrograde when it's at perigee. And again, took another snapshot at my zenith, which is south. My reading on the app for that night was 182 degrees, and my declination angle, as you can see now, it's dropped. It's now at 39 because the moon's on its southern declination. There you can see that straight line I was talking about from that time lapse I captured myself last year. The moon travels in a basically straight line, not quite a straight line, and what you'll find is it always seems to be going curving one way, then always curving down. I've never actually seen it perfectly straight across that line. It's always above it or below it, if you notice, you know what I mean. But then again, you can see the moon azimuth on Moon Calc, 178 degrees, and the declination angle is 39. So just a quick comparison again. I got 182, but like I say, it is really difficult to calibrate the phone app. But the declination angle was spot on that night.
Dave, can I interject again there on that picture?
Yeah.
When we was at the conference, I was sharing with you some pictures that I'd taken of the moon where I was getting. I don't know if you can just go back to that image, but I was sharing some images with you where I'd got the what's the phrase? Excuse the English, to be honest, but the luminosity of the moon, the brightness of the moon in one part of the photograph, and the actual physicality of what you would call the moon in a separate part of the same image. Is that what we're seeing there?
Yeah, I've got that. I've got an image what in the presentation. What I'll show that later on. I've actually captured that. Well, I haven't captured it myself. I actually got this photograph from a friend, but it's the same principle. Yeah, you've got that reflection of the image of the moon.
Yeah. Sorry to knock you off track, mate.
It's
I've just seen that on that picture then.
I've got it in the presentation, mate, so we'll come across that. Like I say, 178 there, a few 4 degrees out on the azimuth, but spot on the declination angle. So another week later, roundabout the moon, you'll see now that the celestial equator there, but the moon is below the celestial equator in what I called the southern circuit. I'd just like to thank my good friend Jose Manuel Silva. He captured that time lapse from Portugal. And there you go again, the moon on the 21st of the 7th, 2017, 21st of March. As usual, what I did, I took another snapshot from NASA's Lunar Reconnaissance visualization. And you'll see again that the moon now is heading towards apogee. So what we should be seeing now is the moon speeding up from an observer's perspective. My final observation reading for this first experiment is 158 degrees, which you'll probably think, hold on a minute, that's not south. But there's a reason behind that. But you'll also see the declination angle is 15.1 degrees. The reason why the moon's at 158 degrees and not 180 degrees is a simple reason, really. I've got a full-time job. Now, if you look at the time in the corner there, it's 5:16. And I have to start work half an hour early, so I actually start work at 5:30 in the morning. Now, it was either be late for work or capture the moon there. And I thought, I'm not going to be late for work, so I basically took the shot there. It doesn't make a hell of a lot of difference, I don't think, but that's the reason why I didn't catch the moon south. Basically, I've got a full-time job, and when you've got a full-time job, a family, and you're trying to make these observations, you know what I mean? You're trying to squeeze a lot in a 24-hour day. And again, you'll see my readings compared to MoonCalc, 159 degrees with a declination angle of 15.1. So 158 and 15, spot on nearly that time. And what I did basically, I basically raced all the moons against each other. Let me just go into full screen here. I got this idea from Stan Smith as well. Basically, what them guys were doing with Z proxy, they was color coding the tropics and the equator. I actually pinched that idea from them. So what I did when I'm relating back to the moon on the equator, I've made the text yellow. When I'm referring back to the moon on the Tropic of Cancer, I've made it red, and the Tropic of Capricorn blue. It's just a reference. As when I'm referring back, it makes it a little bit easier and a little bit easier to recognize. So, like I said, all at times 50 zoom, all at 60 frames a second from the exact same location, shot over a 2-week period. What I did notice, and I thought quite strange, although the moon was on the Tropic of Cancer, it did appear slightly smaller. If you look, it looks a lot smaller than it did there, even though they was all at the same zoom level, exact same zoom level. But this could be atmospheric conditions. You know, if you've got more dense atmosphere or less dense atmosphere, more moisture in the air, it could have a little effect on the actual lensing effect on the moon. So you see that the moon on the equator was the fastest. The Tropic of Cancer was second, and the Tropic of Capricorn come third. In reality, I know this because I've looked on time and date. I'm just going to come out of that. In reality, I know that the moon on the Tropic of Capricorn should have been slightly faster than the moon on the Tropic of Cancer. Now, I believe because that moon image looked smaller on my my screen on my actual camera, that a smaller object would take a little bit longer to travel from one end of the screen to the other. But as you can see, the meridian passing time, that's basically for the moon to occupy one spot and then the following night to occupy that same spot. What I've done basically, I've measured that gap. That gives me a time frame to compare against my observations. So if I see the moon speeding up, yeah, I would expect, if I come on to time and date, for the meridian passing time to be shorter. And as you can see there, when the moon was on the Tropic of Cancer, it took 24 hours and 57 minutes to occupy the same spot. When the moon was on and around the equator, it took 24 hours and 45 minutes. So clearly it's speeding up because it's taking less time to occupy the same spot the following night. And when it was on the Tropic of Capricorn, it slowed down again. What I will show you now is somebody said to me, yeah, the reason why the moon will slow down when it's on the Tropic of Capricorn is because, like, due to parallax. So I thought, fair enough then. What I'll do, I'll take readings from different locations. We know that the readings I'm taking relatively match up with moon calc and time and date. So what I did, I punched in the location for a place called Pontianak in Indonesia, which is smack bang on the equator. Now, if you look at these times here, you'll notice the times are nearly identical. Even from their location, the moon took 24 hours and 57 minutes to occupy the same spot on the 6th and 7th. It speeded up on the 12th. If you notice there, it's actually 24 hours, 46 minutes there. But because of the time difference, I bet if you match the times up, it would actually be 24 hours, 45 minutes. And there again on March 21st, it took 24 hours, 49 minutes. I even went a step further then. I went to the furthest point on the plane where we can actually have observations verified. And that's a place called Ushuaia in southern Argentina. Funny enough, it's on the exact same opposite latitude as the UK, but in the south. And guess what? You get the exact same readings again. So even from their perspective, when the moon is nearer them, you're getting the exact same readings. It doesn't matter where you are on the plane, you will get the same readings on the meridian passing time everywhere. It's not just from one location. And what I did as well, just because I had plenty of time on my hands, I actually measured the meridian passing when the moon was on and around the tropics and the equator for a full year. So as you can see, all them in yellow there is when the moon's heading from the Tropic of Cancer to the equator. What you'll notice is it always speeds up at that point. And as you'll see again, when the moon's heading from the equator to the Tropic of Capricorn, it slows down again. Interestingly, there's not a lot of change in speed when the moon heads back from the Tropic of Capricorn back to the equator. It stays at relatively the same speed.
Can I ask a small question?
Yes.
What exactly do you mean with speeding up?
Well,
angular speed or how?
Well, observable speed.
It goes against the model. This is the whole point. Correct me if I'm wrong, Dave. This is the whole point of your presentation, right?
Yes, because like I said, my observations have evolved as I've gone along, and I'm finding new stuff out all the time. You know what I mean? On my first observation, in my first moon race, I didn't even look at Kepler's law of planetary motion. It never even entered my head. But as I go along and I start digging and digging, I'm opening new doors, and this is what I found out. Now all these can be verified on time and date. Yeah.
No, but is it how the speed is basically derived? Is it through the angular speed?
No, the time.
Or just the overall speed. Path that it motions.
Well, the observable speed, I've actually recorded myself. It's actually you'll see in a minute when I do my other 3 observations. It's observable speed.
So
but that must be angular speed then, like how fast your camera has to turn basically during the observation, correct?
Yes.
Okay,
that is basically angular speed. That's very fascinating.
Yeah.
So let me summarize this, and correct me if I'm wrong, Dave. What you're saying is that when the moon's approaching perigee, which is when it's at the closest point to Earth, it should speed up. However, on the heliocentric model, when it's leaving perigee and it's going back towards apogee, it should slow down, right?
No, it's the opposite way around. Because the globe's spinning, you would see that angular momentum from the point of apogee. Yeah.
What I'm saying is it should speed up on the approach and then slow back down as it leaves. Is that right?
Yes, it should.
But you're finding that it speeds up as it leaves.
Well, yeah. When I make my other observations backed up by the meridian passing readings. You'll see in a minute. We'll get to that. But what I want to show you is, though, basically, I pumped all them numbers into a graph. And what it did, it produced that graph there, which looks like an ECG reading. In fact, the guy who set up all the recording equipment at the convention, he actually works in a hospital, and he says that's basically an ECG reading. Exactly. Now, we know that if we die, touch wood, that to bring us back to life, if we have a heart attack or something, they need electricity. You know what I mean? Everything around us is electric. Yeah, the sky, everything. Now, is it just a coincidence that when I put them numbers in, it come out like an ECG reading? I don't know, but there is like a pattern to it, which is quite interesting.
Dave, we've talked about this on sun and moon and stuff, and it was something that I think some of the guys will know I'm medically trained, and it was something that when you presented it a while back on sun and moon, it struck me, and I used the term QT interval, and that's can I read it, Nathan? Is that all right? Just for a second, the definition of the Q and the T in terms of a heartbeat transmission.
Yeah, cool. Go ahead.
After each heartbeat, your heart's electrical signal in preparation for the next heartbeat. In long QT syndrome, your heart muscle takes longer than normal to recharge between beats, and it's so basically when you see that ECG machine with
it's like a capacitor.
well, if you imagine the straight line, which is slightly below the halfway mark, you've got this kind of electrical signal where you're getting a resetting and then a re-emergence of the beat. And as Dave says, it's strangely like that. And like I say, somebody who's medically trained, when Dave first showed these images, it was something that struck me. I felt the need to mention it then, and really, like I said, there's no logic to it, but I do feel the need to reinforce it now.
Yeah, it's interesting, isn't it? Like I say, I did it. I was messing about with charts, and I did a pie chart, and I got some right mad shapes on the old pie chart, which I might actually incorporate into this presentation eventually. So as you can see, that it's not a fluke when the moon speeds up on the equator. It's all the time, every time. Yeah, and I basically got a full year there, and it's at the same point every time. Right, we'll go back to presentation now. So we've seen the March moon race. I'll just skip that. So what I did here, I just took a snapshot of how I collated my data. I didn't take somebody's word for it and just take somebody else's reading. I physically went on to time and date, and I pumped in every single reading manually myself. And then I got my good friend Robert Scott, who transferred it all onto a spreadsheet for me, and then I've just built up the spreadsheet as I go on. So that's how I found the meridian passing. I basically look when the moon is at zenith, because that's when they always base it on, and all I did is time them 2 points, and that gives me a time frame. And you can see, oh, I'll leave it now anyway. And this is just a quick time lapse of me sat on the computer collating that data. I just wanted to show you that, you know what I mean? I'm not just taking anybody's numbers for it. I'm actually, yes, I'm taking time and dates numbers for it, but I'm actually taking the numbers physically myself to put them into my data. And you'll see in a sec, I actually stretch my back up like that because I've been sat down for so long. There you go.
Well, thank you for all your work.
No problem. It's for a good cause, mate.
Is that the end of the present? There's more, right?
There's more, mate. There's more.
Okay, cool.
Yes. We're about halfway through, I reckon.
Cool. No rush whatsoever. Got all the time in the world.
Okay. So we've seen from an observer's perspective that when the moon leaves the Tropic of Cancer, it speeds up. And then when it leaves the equator, it slows down. Now, it's not a fluke or it's not a one-off. This happens regular. But my interest in the thing I was interested in is what the moon's doing when it leaves the Tropic of Capricorn and comes back on a northern declination to the Tropic of Cancer. So this is where my next set of observations come into it. So again, this time I waited till the moon was on and around the Tropic of Capricorn. As you can see again, the moon's below that celestial equator. If you're wondering what them two lines are there, I think that's Jupiter, and the other star what was below it, which I can't remember what it is, but it begins with S. And my next observation on the 5th of August 2017, because I'm learning as I go, and I'm knowing I need to invent new techniques for my research, I've actually started measuring the radius of the moon. So going forward from this point, I'll be measuring the radius of the moon and comparing the actual size of the moon within my observations as well. I couldn't do it on my first lot of observations because I couldn't be 100% sure that everything was actually shot at this exact same zoom. I questioned that one on the Tropic of Capricorn, where it did appear slightly smaller. That's why I didn't use it. But these ones, I can confirm to myself and everybody else that I shot it from the same zoom and the same position. And as you'll see, the moon, when it was on the Tropic of Capricorn, when it was furthest point south, was 371.59 pixels. Again, like I normally do, I compared it against NASA's moon phases. You can see there, the moon is at apogee, and it's now heading towards perigee. Now remember, the moon should speed up, which I've shown when it's going from the point of perigee to the point of apogee on a globe. We've already seen it speed up, and we've observed it, and it's been backed up by the time and date data. Now it's coming the other way now. You'll see the moon phases are identical. And again, took about to reading. You'll see there, 177 degrees. Again, I'm trying to catch it at zenith, and the declination angle, because the moon is low on the horizon, is only 18 degrees from the horizon. Also took a snap of moon calc, and as you can see, 178 degrees, moon azimuth, and 17.35 declination angle. Just click back, you'll see 177, 177, and 18 degrees. So my observations are actually getting a little more accurate. If you look at the first observation to this one now, I'm actually improving. I'm taking more time because I know that it's important to try and be as accurate as possible. Again, we've seen this one from before. I just used the same basal time lapse. This was an interesting time lapse because it was just turning daytime as well, like in the morning, like as I shot it. So it was quite good. There you can see the daytime coming. And again, on the my second observation on the 11th of August 2017, notice the time, yeah, 3:50 in the morning. You know what I mean? You've got to get up to catch the moon at certain points. If you miss that point, then you can wait up to a month to catch the moon in the right position again. And so it's imperative that you capture the moon at the right time. And as you can see, it's 389.53. So even though the moon's coming towards perigee, it is actually getting bigger. So it actually fits the globe model at this point. And then again, you can see that moon is coming towards perigee again. Same phase. And there you get there again, a diopter reading, 179 degrees, nearly smack bang on zenith. And the declination angle now is getting higher in the sky, and it's at 33.8 degrees from the horizon. Just a comparison with moon calc. You'll see there the azimuth 179 and 32. My readings were 179 and 33. So now the moon's high on the Tropic of Cancer from my perspective, and you'll see it's above that celestial equator, and it's in what I call the northern circuit. This is an interesting picture for two reasons. First thing I noticed when I actually measured the moon is that the radius of the moon had shrunk. Now, I can confirm to you and myself that I did shoot the moon at the exact same zoom on my camera, but it did appear smaller when the moon was high on the Tropic of Cancer. Now, I think there's a reason behind that, and that reason is atmospheric lensing. Because when you're looking at the moon, when it's towards the horizon, you're looking at the moon through more layers of atmosphere. But when the moon's high in the sky, from our perspective, you're looking at it through less layers of atmosphere. So
That makes sense.
We'd call that atmospheric lensing, but ballers would call that refraction.
Yeah. And
Yeah,
now
the sun kind of does the same thing when it sets.
exactly.
It also becomes bigger. So
Yeah.
If you go outside now and look at the moon, you'll see it's really, really high in the sky, right? And I bet you when it looks pretty tiny compared to where it does when it's near the horizon. It'll look so. It's very difficult to believe the globe model when they say the moon should be bigger when it's closer, because
Dave,
yeah.
So is there not necessarily a relationship, but a correlation between Cancer equator and Capricorn and the size of the moon? Is there a direct line, as wobbly is, but is it smallest, larger at the equator, larger at Capricorn, or
it's
unlike the speeds?
It's very difficult because I can't really comment on that because I've only made these observations. You know what I mean? This was going to be my next project. I'm going to start measuring the radius of the moon at certain points, points of apogee to point of perigee, and then I can start building up some more information on that. You know what I mean? So I can add it onto the actual presentation, or just for my own reference point, because that's an area where I need to look in. Clearly, from my perspective, when I shot the moon on the Tropic of Cancer, it appeared smaller. But I would expect that when I'm looking up at the moon and it's really high on the Tropic of Cancer, because the higher it gets, the smaller it seems to appear.
That's interesting. If you add that from, well, maybe not from Ripley anymore, mate, but you know, from Ripley, from somewhere in the equator, and from somewhere on the tropics as well, and to do the comparative moon sizes.
That would be brilliant, but they would all have to do it at their zenith. You know what I mean? We couldn't do a sync one. It'd have to be at their zenith to get the actual size. Because, like I say, when it's rising, it's going to appear bigger. When it's at zenith, it will appear its smallest, I would imagine. So every observer would have to shoot it at the zenith.
That's the good thing from your observations, Dave, that you seem to have. We're kind of musing over this atmospheric lensing stuff, but you seem to have intuitively gone for zenith to minimize that effect. Whether that was genius or luck, I don't know, but it seems a very intelligent way of the time you took the photos.
Should we call it genius?
Yeah, we'll go with that, bro.
So as you can see again, when the moon was on and around the Tropic of Cancer, it's getting closer according to the globe model. There you go. So it's gone from apogee to perigee. This is just a quick helio confirmation. According to their model, when the moon's at perigee, the moon is closer to the Earth and looks slightly larger. Now, I'm going to have to disagree with that for the simple reason, if the moon's high on the Tropic of Cancer at apogee or perigee, it's going to appear the same size, isn't it? How can you compare it with all the different atmospheric conditions? Yeah, you've just got to take NASA's word for it because they're saying it is bigger. But clearly, when the moon is on the Tropic of Cancer, from my point in the UK, it appears smaller, and it always will do.
That's weird. That would suggest that the ellipse is still pretty centered around Earth then instead.
I don't call it ellipse. I call it something else, and you'll see in a minute what I call it. So, as you can see, my final reading. Hold on. Yeah, my final reading there. Sorry, I went the wrong way. Sorry. Actually, that's the wrong thingy, that one. I must have changed the actual diopter reading. I'll come back to that because for some reason I've changed the actual diopter slide. For
No
some reason.
worries.
I'll come back.
Press on regardless.
Yeah. So basically, when the moon, obviously, from my perspective, is high on the Tropic of Cancer, and as you can see, oh no, that's right. That's right. Yeah. Moon azimuth is 144. Yeah, that's right. It's all right. I'm being stupid. It's because I didn't catch it at zenith. That's why. It's all right. I thought I'd got the wrong slide in there, but same again for the same reasons like before. You know what I mean? I haven't at the time now, but at the time, yeah, I had a family, I had a house, I had well, still got a full-time job. So you know what I mean? I couldn't always catch the moon at zenith, but as you can see again, the declination angle 48 degrees. The moon is quite high in the sky. Yeah, but I caught it at 144 and not at 180. And there's the comparison with MoonCalc. I lost my train of thought then. I'm back now. So yeah, as you can see, 144 and 48 spawn. So then again, I race the moon against each other. What you will notice this time, when the moon enters frame, it doesn't overexpose like it did on the first observations. This is because I'm learning all the time. You know what I mean? I've got this camera and I've learned to use the exposure and aperture lock, which stops it from overexposing as it enters frame, which visually looks better. And it does give you a little bit more accuracy when obviously judging it to enter the frame. So again, color coded. I put the moon on the equator on the full screen, and the inlays or the overlays, the Tropic of Capricorn, I did in blue, and the Tropic of Cancer, I did in red. What is quite annoying is the moon on the Tropic of Cancer was actually shot a month later. Now, this is for the very reason I was talking about before. If you've got a cloudy sky, yeah, you're basically in trouble. You know what I mean? You can't do anything about it. All I can do then is wait another lunar month till the moon is in that position. If it's cloudy again, then you have to wait another month. You know what I mean? It's to make observations in the UK with the weather that we get. It is quite difficult because we majority of the time it is overcast. That's the one reason why I didn't do it with the sun, because I've had to wait a year for it to get to the same spot. And as you can see, I'm just going to pause this in a sec. Did you notice how long that moon took on the Tropic of Cancer? It seemed to take forever to get there. But as you can see, the equator, 5 minutes 20 to enter my frame and reach the other end of the screen. The Tropic of Capricorn took 5 minutes 36, and the Tropic of Cancer took 6 minutes 15. So results. I'm just going to go back into my spreadsheet.
Dave, can I be geeky again? And this might probably relate more to Anthony. You might be able to help as well. Whenever I'm doing my P900 shots with stuff, I know you're using a slightly different reduced zoom, and it might be beneficial in this sort of circumstance. You've got better clarity and a full moon at full zoom. I find that the transit is quite angular. It's very hard. You seem to have lined up there a very lateral transit. How did you achieve that, mate, in terms of measurement?
Trust me, it's I can actually give you a demonstration. It's nearly impossible, mate, but I'll give you a demonstration of. Let's just click on this one here. This is a live one.
Yeah, you see, that's more like mine.
Yeah. It gets easier the more you do it, but
so it's basically training.
there you're done.
So are you twisting the camera on the tripod?
It depends when the moon's on the equator. it's dead easy because it travels in a straight line. So it's a matter of just getting it in the right place. You've got to judge before it enters your frame where it's going to come on frame. You know what I mean?
Yeah.
And like I say, you've only got one try at it because obviously when the moon's at zenith, it's not there for very long. So you've only got like a couple of attempts to get it. So you've got to be pretty good at doing it, and it does take practice. So that's just like a live. That's a live straight from the camera. That one, real time one. All my observations in the presentation are all done at ×4, but that's a live one. Is that all right?
Yeah, I'm sorry for being geeky there. So you are twisting that tripod X, Y, and Z.
Yeah, when it's on when it's on the Tropic of Cancer, the camera's right up in the air, and you get the angle, and it's like all over the place. It takes a long time to get used to doing it. You have to practice, on different nights. You know what I mean? It's not just a matter of doing it on the night.
No, mate. That honestly, genuinely, that's why I was asking, how the bloody hell have you done that to get those lateral transit? Just seems, a little bit more than hit and miss. It does seem like it requires a hell of a lot of failed attempts. Bro.
Yeah, practice makes perfect, mate.
Yeah.
That's what I say.
Sorry.
So my observations on the August, as you can see, it took 24 hours and 49 minutes to occupy the same spot. Now, interestingly, the moon should be slowing down in its cycle. No, sorry, it should be speeding up in its cycle. Slowing down in its cycle. Sorry, get my facts right. Yeah, and as you can see now, when the moon was on the equator, it took 24 hours 48 minutes. Even though it's only 1 minute difference, and I've actually took a snapshot of time and date to prove this as well, because like I say, I could just put these numbers in here and you've just got to take my word for it. But I've actually took a snapshot of time and date for this. So when the moon's heading towards perigee, from a globe perspective, it would appear to retrograde. So how can it speed up when it's heading from the Tropic of Capricorn to the Tropic of to the equator? It shouldn't do it. It should be slowing down in its cycle.
Yeah, that's the whole point of this. And for anybody that's not with all the data, now let's be honest, it's quite swamping. And I don't mean that in a bad way, Dave, but the point is the moon should be slowing down at this point, but it's actually going faster.
Exactly.
And it's very mysterious.
And Annie, you're so right there. Genuinely right. This stuff is so mind blowing as you try and juggle the ball model, the flat model, and try and comprehend the data that Dave's given you. It was the reason I jumped in, just to try and ask a few questions, because I've sat through this 2 or 3 times over the past year. You know what I mean? And
yeah,
it's hard to get your head around. But what you can't see is it's not marrying up to anything at all. If you try and put those, for the sake of let's use the Pac-Man model, for example, which works in so many other ways, individual ways. You put this data on there, it wrecks that. I mean, it wrecks everything, Dave. But these are clear, synthetic observations, and that's what, for me, is the pinnacle of what you've got there. These are zetetic observations, and whatever model you've got, tough luck. Dave's observations don't work.
Well, that depends if you use in your model a physical path for a physical moon traveling.
Yeah, and also what you have to consider is that I'm referring to celestial phenomena.
Yeah.
In the majority of this presentation, not terrestrial. The celestial is measured in declination, and the terrestrial is measured in degrees. When I'm referring to poles, I'm not talking about geographical poles. I'm talking about celestial poles or poles on a magnet. So I'll just confirm that now. So, like I say, the sky, yes, it's related to the land, but I'm referring to the sky. Now we'll just have a quick look at the time on here. So when the moon was on the Tropic of Capricorn, it took 5 minutes and 36 seconds to enter my frame and reach the other side. Interestingly, the meridian passing on that night was 24 hours and 49 minutes. Now, when the moon was on the equator, it took 5 minutes and 20 seconds, so it was speeding up on my screen. And guess what? The meridian time was 1 minute shorter at 24 hours 48 minutes. So what I'm observing is actually happening in reality. You know what I mean? It's And this last one just proves it, because it took 6 minutes and 15 seconds to enter my frame and reach the other side. But look at that meridian passing time on there, 24 hours and 57 minutes. It matches up perfectly with the observations I've made. Now, here's the snapshot I've took from time and date to confirm it. Now, if you look on the 5th, what you'll see, you got 11:39 till 12:28, which is exactly 24 hours and 49 minutes. And then on my observation on the 11th, 3:40 to 4:28, guess what? 24 hours, 48 minutes. So that's confirmation that the readings I'm taking are matching up. And that's proof that the moon shouldn't be speeding up when it's heading from Tropic of Capricorn to Tropic of Cancer at that part of its cycle.
No, it definitely shouldn't be. Definitely.
Well, it can't speed up both ways, can it? And what I've showed, it's speeded up both ways. It should follow Kepler's law of planetary motion, the second law, which is the equal area and equal time law, which states that the moon should sweep out equal areas in equal time. Yeah. So what you should see, you should see a gradual increase to one point and a gradual increase to another point. But what you will notice is, if I can just go back to my what you'll notice is, look how the moon, the angular momentum of the moon, it happens in a very short period of time. It happens within a few days. You know what I mean? You should be seeing that momentum over a 14-day period, a gradual increase and then a gradual decrease. But look, it slows down and speeds up in a matter of like a week, which is half the time it should be speeding up in. So you know what I mean? It's not following Kepler's law of planetary motion, which is equal area and equal time. It's clearly not doing that.
Dave, can I just
gradual change? It's pretty abrupt.
Exactly.
Yeah, just look at it. If you look at the variance difference between those dates, you've got. If you try to follow that as a circular motion, it doesn't make sense, because you've got 57, 57. So 0, 1, 3, 3, 2, 2, 2, 2, 1, 1.
It disproves orbital mechanics, basically.
Yeah.
Yeah.
Yes, exactly.
Kepler's law is disproven with.
Get the drunk Australian on quick. Disproved orbital mechanics.
The newspapers took the mickey out of me when I presented this.
Of course, they took the mickey out of you.
Yeah.
Took the mickey piss out of everybody, mate.
Dave, they hit you hard, mate. I've noticed that, bruv. You were one of the. It was constant.
Yes. And I got in trouble from work as well, because they mentioned my name and my occupation.
They kept stating your qualifications as if working as an NHS manager was either positive or what the hell relevance was it, other than to A, create problems for you, or to B, deride the validity of the observations.
Exactly.
It was absolute nonsense and pathetic.
This is analytical data. It's repeatable. Anyone can do it.
Exactly.
Doesn't matter what your degrees are. You don't have to have pre-knowledge. You just have to do the work.
Unless the mainstream media, Arwen, and keep stating before you give this observed, repeatable data that Dave's an NHS manager who works blah 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 blah, nothing to do with mainstream Brian Cox science. You know, unless if you keep drilling that in, and that was the point I'm making. It was obvious the derogatory nature that they gave Dave as an intro. It wasn't insulting.
Free indoctrination.
Qualify him in the field he was talking, and as you say, Arwen, these are results that anybody in the proper zetetic way can go out, do, and repeat themselves. So Dave's day job's irrelevant, man. What you have got is a dedicated bloke that's given us all huge heads up. I mean, the kudos, Dave. It's the more I learn,
very meticulous work.
I learn.
What I just want to do now, I just want to highlight all the meridian passing times there. And if you look down there at the average, we all know the mean time of the moon, don't we? 24 hours and 50 minutes. And it's exactly the same on there as well. Just another little thing I picked up on. There you'll see there, look, the average, 50 which is obviously added the 24 hours, and you get the 24 hours 50 minutes, which is the mean time of the moon.
Sorry, Dave. Let me just. So you're saying they're your observational results, and from all of your observational results, the mean time of it is what the heliocentric model states.
All I did then was measure the meridian passing from time and date, but I put it all into a spreadsheet, and I was just confirming that when I do highlight the full year, it does give you the mean time of the moon, which is 24 hours 50 minutes. That's it.
So on average, your results average out to be accurate to
Well,
current known observation.
I showed
there
my
might be variance in each individual result, but that shows that we're not dealing with kooky, nonsensical results. We're dealing with results that
exactly
when you detail them and observe the statistical relevance of them, they match up to current paradigm as well, which is validation to.
Yeah, and there's your proof from the results where the meridian passing time matches the observation perfectly, and the times all match up, which I've backed up by time and date. Yes, I am using mainstream stuff to back it up, but I'm using it in a different way to what you would expect me to use it in. I'm basically using the meridian passing information.
No, sorry, I don't mean that. I mean,
yeah, no, I understand what
you're clearly demonstrating is you are observing the same cyclical event, and that's demonstrated by your averages. Is what I mean, David. It's demonstrating that your results aren't out of sync with known observations, but the data you're presenting and the way you're presenting it is again highlighting maybe some of the things that we've been not allowed to focus on.
True. Right, I'm going to move on now because it's getting quite on. Yeah. So basically, magnetism versus gravity. I took this out of a book called I think it's called Ether and Gravitation by William Hooper. It's an interesting quote out of the book. It says, if either of these forces is to be done away with, it must be the mysterious, intangible, unphilosophic attraction of gravitation, which must be replaced by the philosophic and known attraction of electricity, which can be traced to a physical medium, the electromagnetic ether. So basically, saying there is that gravity doesn't exist, and the only true force in nature, which they quoted me on in the papers, is the electromagnetic ether. Now, interestingly, in the book, he actually basically dismisses the ether later on and goes back to gravity. It's an unbelievable how he does a U-turn.
Oh, we've dealt with this subject very extensively on the debates as well, and personally, I just I accept gravity for a separate force. I disconnect it to magnetism because magnetism has other types of properties, mainly fields and influenceability, and the gravity. And in this case, I mean the downward acceleration force is basically a force that has no causal explanation. We can't emulate it, we can't take it away, but it is measurably there. It's the downward acceleration force. And
are you mentioning gravity again?
Yeah.
You do realize you're banned from that word, right?
No.
Yeah, you are.
No.
Well, let's just.
I'll win, mate. I'm
just saying that
take some shit.
People call it electromagnetism, but
yeah, let's just move on.
It's very hard to prove that as well.
What we're seeing here is the vortex motion created from a magnetic field. Yeah. So the question what I asked myself, so what do these trains in Japan run on then? Do they run on magnets or do they run on anti-gravity?
Magnets, I believe.
Magnets, but they're local and they have a measurable field and they repel specific material, and gravity applies to all materials. And downward acceleration force, I mean.
Okay, let's move on.
Magnets, aren't they? I believe.
So my hypothesis, a lot of people might think I'm crazy, but I don't care. This is what conclusion I've come to from all my observations. And many of you may know that I've always believed in a long time, probably about a year and a half, that the moon, from our perspective, is some kind of projected image, and this photograph, I think, is a good way to try and explain that to you. So what we're seeing in the sky, yeah, is a bright light. Yeah, that is an overexposed image of the moon. And what that does, it actually created a reflection glare on the camera lens, which created an image of the moon.
Nice.
Now I'm trying to now think about this on an epic scale with the atmosphere acting as that lens. Yeah. From our perspective, this is what I want to try and explain what the moon is. Yeah. I'm not saying it's a physical object. I'm saying it's a projected image from the source light. What's beyond that source light, I don't know, but I'm just saying from my perspective, yeah, it's possible that we are looking at a projected image when we look at the moon in the night sky or the daytime sky.
I agree.
I agree with you there.
Yeah.
Definitely. All the heavenly bodies, in my opinion, are just light
bodies.
phenomena, and they don't have physical, literal positions. Even when you change your location of observation, then so do the observed heavenly phenomena, including the moon and the stars. So
My only
Owen, doesn't this one? I've followed you with that, and this is kind of one of these observations. Dave said he'd bring it up earlier, and I mentioned it. It's an observation I've done, and it's kind of one of those things that when you talk about there not being anything physical, it kind of puts a seat to the light source that we then see. So you've got the opposition to your statement that it's just a light, an apparition of a light source. But what we appear to be seeing here is both the apparition and the source in the same image. And that's why it interests me so much. There's one other bit I want to add, just Dave, the bit that I noticed with your photos is there is a much bigger gap between the apparition, I'm liking this phrase, and in the realms of dirty air and stuff, the apparition and the actual physical image of the source, you've got a much bigger gap than I did on if you look at my YouTube video where I've got the two separated. You've got a massive, even the halo around the apparition is separate from the image. That's
I just wanted to say that image is not my image. I did get it off somebody else, but it is a genuine photograph. What was taken, and Jose Manuel Silva took one with his camera. He got the same effect from using one of them telescopic lenses what you put on a smartphone, and it gives him that same kind of effect. But the main point I'm trying to explain there is that bright light created that image, yeah, and it shouldn't have done in my eyes. So.
Right.
So,
hey, Dave. Oh, sorry.
Go on. Before I start this bit, because there's a lot to remember on this bit. I'm doing this is all from the back of my head. I've got nothing in front of me. I'm just doing it all from thought. But go on.
Okay. Yeah. I had a question, and since you're a trained celestial observer and you've been around the world, maybe you could help us solve a little riddle. And that is, we've been pondering a lot about the heavenly bodies, mainly what I now call the globe of the heavens, and that is the stars that rotate around the North Pole star, clearly. But there is kind of an unsolved mystery of it, and that is there a south celestial pole? Is it really there? Because the evidence concerning this seems to be inconclusive. Some people claim that it is definitely a point, a clear, distinct point around which the stars rotate in the south, but others say, nah, you can't ever see it. You can never see that south point, and it could also be more like a cup, basically rotating. What is your opinion on this?
Well, when I'm referring to the sky, like I said before, I'm talking about celestial phenomena, and we're talking about poles like on a magnet. Yes, I do believe that there's two poles. I believe there's a North Pole and there is a South Pole. Now, you have to take into consideration that the North Pole Polaris is not in the center. It's half a degree off center. If you zoom in it with the camera, you will see it making little concentric circles. If you zoom in on stellarium and fast forward the days, you'll see it making concentric circles. It's not in the center. It appears to be from our positioning, and the same. You'll get the same kind of star trails from the south, which I will show in a minute. But there doesn't appear to be a central star like there is in the north.
It doesn't have to be perfectly in the center, but rather the overall motions. And have you observed the literal south celestial pole with your observations? Have you?
I haven't, but I've borrowed my friend Paul Kofo's observations from New Zealand, which I use in this presentation, where he faces his camera south and the stars rotate in a clockwise motion, which I'll get to in a minute.
Yeah, okay, but so it's second-hand information again.
Second-hand information from a very good friend of mine in New Zealand, yeah. So we know that matter exists in three forms. We've got solid, we've got liquid, and we've got gaseous. Now, there may be another form, which may be the electromagnetic ether. Now, the ether is a luminiferous substance for the propagation of light, and it's in a constant state of flux motion, and it carries all the heavenly bodies according to their varying heights and various densities. And it's made up of two great vortices, one in the north and one in the south. As you can see, the stars in the north, when I point my camera to the north, rotate in a counterclockwise motion. And my good friend Paul Kofo, who shot this from 35 degrees in New Zealand, the stars rotate in a clockwise motion. Now, you can deny it as much as you want, but the facts are the facts. I suppose them in New Zealand can say we're lying and we're just making up the northern rotation star trails. You know what I mean? I trust Paul Kofo. He's a good friend of mine, and he's not the only person I know who can shoot a star trail pointing south.
You don't have to make up anything. They're going, all the stars, sun, moon, go from east to west. This counterclockwise, clockwise junk, you could just trash it. Right? Left to right, right to left, counterclockwise, clockwise, all of them. Rise in the east and set in the west. Thanks.
Right.
Well, that's the same on both models, though, isn't it? To be fair.
Yeah, but
Yes.
remember, we're referring to celestial phenomena. So basically, the sky, we're looking at a magnetic field. It's basically a magnetic field. There you can see you've got the vortex motion from a magnetic field, which rotates in one direction, and the south pole of that magnetic field rotates in the opposite direction.
Yeah, that's what I'm talking about. The opposite direction, clockwise, counterclockwise. Now, from our position, east to west, all the stars, the sun, the moon, rise in the east and set in the west.
Right. So let me just carry on with the presentation. So the from my hypothesis, yeah, when the moon leaves the Tropic of Cancer and heads towards the equator, it will pick up on the ethereal currents in the southern vortex, and it'll be circling in the opposite direction in the southern circuit. That may sound crazy, but this is the conclusion I've come to. It is debatable. Like everything we talk about in regards to flat Earth, everything is debatable. But this is the conclusion I've come to. And as you can see, when the moon gets northern declination, it will cross the celestial equator and pick up on the northern currents and be circling in the opposite direction. If you take a time lapse from the equator, what you will see, you can actually see both magnetic fields where you have a counterclockwise motion in the north and a clockwise motion in the south. This is to try and give you an analogy of what I believe is happening above us. So as the moon is circling in the northern circuit, as it expands its circle, it will pick up on the ethereal currents and be circling in the opposite direction in the southern circuit. That may sound a bit crazy, but if you go on to Mooncalc and you go to 70 degrees north, what you'll see is the moon will actually circle you circumpolar, and it will be visible for 24 hours. So it will spend the first 2 weeks turning one direction in the north, then the second 2 weeks it's going in the opposite direction, visible for 24 hours, circumpolar at 71 degrees south. I actually named that the lunar Lima. It's basically the Anna Lima like the sun, but for the moon, and I've named it Lunar Lima. And here's a little snapshot of the Lunar Lima, taken over a lunar month. As you can see, you've got that figure of 8 point. And another one I added to it, which I thought was a nice image, where someone's done a similar thing and they've took a little snapshot each day over a lunar month. So one of the big questions I got asked me, that if the moon is making a figure of 8 pattern in the sky, which I believe it does, how can we see it in the north if it's on the southern circuit, or vice versa? Well, I'm sure you've heard of this little thing before, haven't you? Refraction. So when the moon does get southern declination, what will happen with the projected image of the moon? It will actually refract. So as it does get southern declination, it will actually appear to project into the north. So you imagine that straw getting further and further to the ground, that this part of the straw will actually be producing a more angle level to the horizon. And that's how I think we would possibly be able to see the moon on the circuit from the opposite observational point. Does that make sense?
I don't know. It seems slightly like still a physical location type of interpretation to me.
Yeah, I'm just trying to give an analogy of it. It's quite difficult to put these things in words.
Yeah, I've heard the explanation type before. It can be entertained. On the other hand, the refraction through water and glass is a lot stronger, and like a magnitude stronger than through any type of air thickness. So
I do understand that.
It is inconclusive, basically. It's hard to tell.
Like I say, everything we do, you know what I mean? It's, you know what I mean? We have to, this is why we're doing this, you know what I mean? I'm just hoping that I can find one piece of the puzzle and basically contribute to where we live, basically.
Absolutely. I just to emphasize, I greatly respect your efforts and your work, but this is the Flat Earth debate, so
cool.
We will.
That there was just a daytime.
I will address it. That is all.
Okay, that was a daytime shot of the moon, just to show that the moon does actually emit its own light. I don't believe that the moon is reflecting the sunlight, even though it is relatively pointing at it the majority of the time. So what is the moon? I mean, sometimes it looks like a rock. Sometimes it looks like it's translucent. Yeah, it's a sphere. It's a disc. It emits. It reflects. It does all these things, but still, we don't know exactly what it is. Although the word month is derived from the word moon, and the word lunar is the word lunatic is derived from the word lunar, we still haven't got a clue what the moon what it actually is there for. And I think we could probably observe it for 1,000 years and still never know what the moon is. But one thing I definitely know it's not, and that is that.
It is ridiculous when you look at that now from the perspective that we're all at. It's just ridiculous. Yeah, have to accept.
Oh my god!
I get that effect. I get that effect on my phone when I click one of the settings, and it does a better job than that. I'm sorry.
It's stupid.
It looks like a clay tablet, basically moving over a picture of the Earth.
Do you know what? Everybody ridicules flat earthers, right? But I'd rather be a ridiculed flat earther than have to accept that nonsense as truth. It's ridiculous.
Can I say it wouldn't be a picture of the Earth? It would be an image of the Earth.
A composite, but even better.
Composite image, yeah. So this is just a 1,000-piece jigsaw puzzle of the lunar rover, and it's just to basically said that maybe one day I might be able to contribute one piece to that puzzle, and like I say, help to understand exactly who we are and where we are, and that's what I tend to do for the foreseeable future. And if I can awaken some people on the way, and that's what I want to do. That's it.
Dave, you haven't reached any 100% conclusive conclusions yet. You're still investigating.
Well,
Absolutely awesome.
This is an ongoing investigation for probably for the rest of our lives, isn't it? You know what I mean?
Yeah, I absolutely agree with you. I've only just started on the moon and what it does in the sky. It's fascinating.
One thing it's not doing, and that's sticking to Kepler's law of planetary motion. That is provable.
Dave? Have you seen the flat Earth model when it comes to libration that Chris Monk-Seeley did?
No, I haven't, mate. No.
Nathan, if you're there, Nathan, or listening, if you could dig it out and present it, show it, because you know what libration is, right? It's modeled on a flat plane equally, and it does the exact same thing. When you see it how it's done, it's just blatantly obvious. But until you see it done, it's like, so go on then. It's one of those things that the ballers would say. So go on then. What's libration on a flat Earth? And now they've never done that. It's not one of the arguments they've ever made. But at least it's something that we've been able to work out. We can actually reproduce. And there is an explanation for it, and libration on a flat plane is a thing. So that it's just bizarre how crazy it turned out that we ended up modeling that. It was very much on the fly as well.
I'm gonna have to go now, guys, because it's really late, and I'd love to stay and talk a little bit longer, but I've got to be up for work tomorrow morning. Plus, I'm on my own data.
Dave, join us again.
Well, thank you for all your information.
Yeah, you've got a lot to offer us, Dave. Come back again.
Yes, it's been a pleasure. I just wish I had a little bit more time, but like I say, I'm actually on my own data now, and it's getting late, so I'm getting ready for bed and get ready for work tomorrow.
Good man, and good night.
Okay, thank you for letting me come on and do the presentation.
No worries. Pleasure. Thank you for being here.
Thank you, guys. Bye-bye.
Bye-bye.
Bye-bye. So go on then, Globetards. How are you going to explain that? The moon speeds up as it enters and leaves. That's a bit of an issue. And I can make a prediction a la Rumpus as well. There won't be a single response from any baller.
Don't count your chickens.
How are they going to explain? How are they going to explain that away?
Yeah, that's my question to everybody. Heliocentric or geocentric, it doesn't matter what's happening here on Earth or what we can observe. A heliocentric system is fundamentally flawed.
Yeah, but you can't ask heliocentric or geocentric because that implies that there is Earth and there is gravity and there is.
Yeah, it all leads from there, doesn't it?
Has Nathan died?
Yeah, I'm here. Can you not hear me?
Yeah, but you broke.
Can now.
We only heard like the odd word.
Yeah, I was listening.
So what do you think of that? The moon speeds up on the approach to and the leaving of perigee, right? That's a bit of an issue.
Cool. Very cool. I like globe busting demonstrations when we're in Globebusters time slot. There you go. This is libration on a flat plane.
Oh, I hope Dave's getting to see this.
Stick it on again. It plays it at the beginning. No audio, but this is just a little cutout bit from a hangout Chris, Anthony, and myself did. There you go. You can probably see it rotating around.
And that to me makes more sense than anything that they come across with for libration.
I'll probably get disagreed with by Nathan here, but
no, it'll be Arwen.
For me, Anthony, all this stuff, it's not about model swapping. It's about using the data available to either accept and continue to investigate a model or reject a model. You know, and most of the data we have, we can reject a ball model. That this enables you to reject the heliocentric model. But I do think it really does ask a lot of us flat earthers a lot of questions as well, because the data doesn't fit in anything that I can think of. You know?
Well, a projection it does. I'm not against it being a projection of somehow. The only thing that puts me off it being a projection is that someone's got to change the bulb every now and again.
Right. So, and that's when it gets that bit that I was talking about, the dual image that I kind of got onto Arwen. I said into chat when I want to have a chat with him, because, you know, Arwen and you guys, when you take a loader, or certainly Arwen takes a load of flack with regards to this light show. But that kind of demonstrates, even whether it's close, it's far away, whatever it is, we're clearly seeing there, whether it's just an optical effect of the lens, which seems to be too recurrent, which would suggest it's near anyway. It just keeps happening, and there is the two images, the luminosity and the actual solid object itself. And it's been noticed by everybody. You know, Walt's done a load of them like it as well. And I wonder whether the apparent difference has some measurability between it as well. That's the only other thing, because this is noticeable and repeatable again with lenses.
I didn't quite follow what you were saying there, Iron Realm Media.
It's Adam. Sorry. Yeah, I'd logged in on the wrong computer, mate. There is, as we were saying, in terms of when we think about the
sorry, Adam, one sec. That image that's on screen right now, Mark, is an example where the sun, or I don't know if the moon does it. I've never noticed the moon setting, but the sun does change its shape whilst it's setting. Sorry, Adam. Carry on, sir.
No. I mean, it's not so much that. It's we talk about measuring and making observations of so, and we all heed against it in terms of its influence to the shape of the Earth. But the point I'm making here is really actually there's a much bigger influence as well, that actually, as we can see with some of the Dave's, and it was in both the Optra observations and a lot of the other stuff he saw, and I'd say lots of other people repeated it, we're seeing the illuminated object that probably is the thing we see with our naked eye. But when we zoom in with decent lenses, we can see the illumination occurring in the atmosphere, but it's separate to the object which is supposedly causing said illumination, as with Dave's pictures. And like I said, it's not the first I've made those observations, posted it on my 4 channels I've put on my YouTube thing, you know what I mean? It's one of. So I think it lends to really questioning the level of any accuracy or inference you can draw from any celestial observation, because you don't even know what you're measuring. You're only measuring what you're seeing occurring in the atmosphere is. And that lends to the sun as well, as Anthony's saying. Now you get the different shapes, because it is literally an image occurring in an atmosphere. and that atmosphere requires a certain density before it becomes opaque enough to form the image, is what my...
I may be asking a question that's dated by a day or two, but have we all seen Karen B's latest video about the sunspots on the sun?
Yep.
I haven't.
Wanted to see that, mate.
I debated on the show earlier.
Oh, you right? Okay, so I've missed the last couple of shows, but I mean, she shows that the sunspots are not moving around anything like what they tell us. The sunspots are not doing what they tell us. So whatever the sunspots are doing, who cares? We don't know. But what they're not doing is, again, it's like the curve that is not there. It's like the axial rotation that's not there. We don't know what to explain or how to explain this stuff. We just know that it's not consistent with what we're being told. Check it out, Karen B's latest video. It's really, really good.
Talking of inconsistencies, I don't know if John's still around. At the beginning of the show, he was saying that you've got a whole list of global inconsistencies. I don't know if you can you hear us, John? Are you around?
Yeah, I'm still here.
Good
You got
man.
those to
What have you got
hand?
to show us?
Oh, we could talk about, Anthony just brought up the sun and those sunspots. I did check out that video, but we don't really even have to go there. I mean, the standard model of the sun currently in physics is a second law of thermodynamics violation. just on its face. So it destroys it right there. I mean, going into sunspots and all that other stuff where you're just beating a dead horse. Right?
Can you dumb that down? What do you mean? It's a second.
Yeah, I'll tell you what, let me go ahead and present and I'll show you what I mean.
I thought you were going to pick Dave up when he said about his results and he called it his hypothesis. And I thought, I hope John's asleep here.
I almost Skyped him saying, calm down, it's okay.
Say that again, Nathan. I didn't hear you.
I said I almost Skyped you and said, no, it's okay. You can correct him after.
No, too funny. All right, just tell me when you can see this.
Yeah, you're up.
All right, like I said, the standard model of the sun states the sun is more or less a nuclear reactor, right?
Yeah.
So here we go. Here's the sun. Can you guys see this? It has the photosphere or the inner core. The photosphere is the surface of the sun, chromosphere, and then the corona, correct?
Yeah, go on.
And yeah. I don't
Are
know
you
if
asking
you
us
can
to
see
say that that's correct?
Well, we accept that is the model they present us.
Yeah, I'm joking.
Yeah, that's what they tell us, right?
Yeah.
Now, I don't know if you could see this temperature. It's even blurry for me on here. You probably can't see this, but the scale here is from the photosphere. It has in millions degrees Kelvin here on the y-axis, and then the distance from the sun on the x-axis. Can you guys see this okay?
Sounds like another story to me, this, John.
Yeah, I'm going to pummel it here in a second. Well, it's already pummeled if you could just look at this right here.
Yeah, we can see it. Go ahead, son.
Yeah. So on the photosphere right here.
Doesn't it go up and down?
Yeah, I'm getting a bad echo.
Yeah, who's causing echo? Just mute if you're not chatting, please.
Yeah, on the photosphere, it said that the temperature is 5,800 Kelvin. I'm getting bad reverb, guys. Somebody's got their watch page open. Okay. So as you can see on the photosphere, the temperature dips down on the photosphere. It's about 5,800 Kelvin. The inner core is back here, right? So no problem. The temperature is going down as you're getting away from the core. And then you could see that the temperature slowly starts to rise here into the chromosphere. It's getting further away from the sun now. And then look what happens to the temperature profile here from the chromosphere to the corona. Look at this parabolic jump, right? Let me explain this to you.
How did they measure that?
I hope you see the problem. So the inner core temp of the sun is 15 million Kelvin. The outer surface of the sun, the photosphere, is approximately 5,800 Kelvin. On its way to and through the chromosphere, the temperature slowly rises, then goes parabolic, like I said, right through here. from 10,000 Kelvin to 500,000 Kelvin, right? When nearing the corona. And then it goes from 1 million Kelvin to 10 million Kelvin, right? This scale doesn't even do it justice. This goes parabolic again, right? You see the problem? You see, the fairy tale pseudoscience priests collectively missed the lectures on the second law of thermodynamics. Heat really does flow up parabolic hills. This is tantamount to standing near a wood stove, then moving back 500 meters because it's too hot, and then you spontaneously combust. That's how ridiculous this is. Right?
10 million Kelvin, wouldn't that just even disintegrate plasma, basically?
Listen, I'm just going by their story, man. This is a joke. Like I said, and you don't really have to go into anything else. Like the sunspots, that stuff's very interesting. I enjoyed watching it. I enjoy watching all the debunkings, but you're beating a dead horse. All you need is this right here. This does it right here. So, second law of thermodynamics violation. Any questions?
Nope. That sounds pretty concise to me.
Yeah, we could go to the solar winds. They're the same type of deal. Not a big deal. It's the same
story.
It all seems to me like a bunch of basically sun model theoretics, because how did they even get to that temperature? Like,
you have
how
to
can
talk.
you even start to analyze any of it? Like on the layers,
You have to talk to the Sohu guys.
Right.
Robert,
I've got a question. If you've got a second, if you just scroll up to the graph.
Sure.
Okay.
Which one? This one?
Yeah, perfect. And so when we talk about like the ISS, and because we guys were talking about it with Rob Durham and that in terms of vacuums and temperature. So first of all, we have to consider what the temperature is in terms of its consideration of how we're going to measure it, because we're measuring degrees of vacuum off of this ball, or relative densities, I would suppose.
Oh, we'd have to stop at the vacuum, but that's another step. You know that deal, right? Yeah,
we got into that on Friday. It was a great stuff with Rob and some of his actual temperature vacuum, which means why did I waste money on double glazing? I don't know. But as we look at that, you've got that huge incline there, and I just wonder if you could just kind of show where the huge tenfold increases in temperature in terms of the image above, into the actual physicality of what we're proposing.
Oh, right up here. Oh.
Yeah, exactly here. So
on the cartoon,
we're moving from
the inner core, but this graph right here is mainly going from the surface. The photosphere is right here on the Y and on the X.
Sorry, what I'm meaning is that the main transition is we get into the corona. So the main excremental increase in temperature difference throughout that big blobby ball thing there is when we get to the point where within a vacuum system, we're told that temperature is relevant to density of an object. Yeah, suddenly all the heat is occurring in this coronal area where we're basically losing any solid matter, and it's divulging. And I wonder why, if you knew if there was an explanation as to why they proclaim that's when it becomes hotter, when under their ISS rules of heat, once you stretch that heated up matter out, it becomes less ability to transpose that heat. So how you could get the much higher figures there. I know it's nonsense. I'm just humoring them.
Yeah, I don't know how to explain the nonsense.
Maybe I could give a very speculative explanation based on gravitational pull. Indeed. Now, this is pure science fiction, by the way, but I have thought about this decades ago, and could be that, like, more to the center, gravity is so strong that it basically prevents the combustion effect, so that more to the surface, the lighter material basically really combusts to their maximum potential, which then causes the heat on that specific layer when it is just sufficient enough to escape the compressive effects of gravitational pull. Is that a good science fiction explanation?
You're saying gravity pull the heat in?
No, the massive gravity from the sun, which is a huge object according to science, the gravity is so strong that it could prevent the combustion effect. Basically, so the massive pressure prevents it from combusting properly. It should be working for NASA, actually. Like,
Yeah, it does sound like
I concur.
sounds like NASA
Okay.
bullshit, doesn't it?
good budget there.
I think the point I don't know if I'm right explaining it. I agree with that. And maybe that's a point of retardation towards the center of the sun that you could.
It is a ridiculous concept, but
what I'm saying is if you've got a thermodynamic reaction contained occurring within a material that is of a said density, and then you take that same thermodynamic reaction occurring and apply it within a much less dense environment, what that graph is suggesting is that the less dense environment generates a much higher heat, even though you've got less thermodynamic reactions occurring at any specific moment. That's what I'm looking at in that graph.
well, compare it to hot coals, like a pile of hot coals.
No, forget that, John. Sorry, Owen. Just is that my comparison correct from your understanding, John? Before we go off on another.
Yeah, I would suppose so. But I mean, we're just going off of what they tell us.
I know it's bollocks, isn't it?
Yeah. So it's hard to explain this with bollocks because it's just bollocks. I have a difficult time. As soon as you bring in this vacuum, all bets are off the table. I mean, I'm chasing invisible three-toed gnomes and trying to explain heat through invisible three-toed gnomes. So
yeah,
it's very difficult to explain it. Now, listen, they recognize this, but they just whistle past the graveyard, right? Even when I was on Robert Pisano's channel, when he called up that Sohu guy, they stuck the sun directly. This guy brought up the paradox, and Robert didn't jump on him. He let him go because he wanted to get to other points, but I nearly fell off my chair. But these guys know this problem, right? But they just whistle past the graveyard and continue on with the fairy tale. That's what they do.
I think that's the point I'm making. That's the fairy tale that I've just, as I looked at what you presented to me, fresh, that's what I saw. It didn't make any logical scientific sense. And that, what the ramble you heard from me was trying to correlate that graph with that picture above. And as I said, with regards to my understanding of how we're told heat transfers in a vacuum. And that's a vacuum enclosed system.
Yeah, no, how would he?
It is trying to like explain bullshit when you know that it's bullshit. But I was literally trying to explain my understanding of the bullshit. If you makes sense, not excuse the bullshit.
Well, technically, with the whole gravity system, the gravitational pull system, either the sun would be more like a pool of liquid fire, or it would be constantly venting off giant amounts of plasma gas in all directions. So that would be the logical system with a very heavy gravity setup and the giant amounts of heat supposed to be generating. So,
what type of gravity is that? Oh, never mind. No, don't worry about that.
Yeah, you know which one I mean. The ball one.
All right, we good on this one? Any other questions, comments?
Oh, sorry, dude. I'm sorry for sending you sideways. It was just
No. That's okay. No, but it's a stone cold second law of thermodynamics violation. You just put a hard stop right there, and then you move on to the next fairy tale. No sense in, beating this dead horse to death, right? It's over right there.
Love it.
All right, let's see what else we got here. I compiled this right before we come on because these points have been coming up. Let me see where we want to go. Oh, Soundly. Do we want to do that? Yeah, let's do this. I mean, okay. So the Lake Pontchartrain power lines. Number one, before we start here, has anyone on this panel lived in Louisiana?
Nope.
Anyone?
No, but Ramsey describes it as a swamp bowl.
Yeah, it's a giant swamp. Louisiana is a swamp.
I
Lots of
think
mosquitoes,
we could
hot and moist.
we could be kinder about my Iron Realm Media's friend Walter's native environment. He's not too far from there, so he's near Baton Rouge, so not far away.
Yeah, that's still right in the
Still
lane.
sweaty.
Well known, very hot and moist both.
That's right in the lane. Okay, so I lived in Louisiana for 2 years in the military. Let me tell you something. You could walk outside with a knife and you could go ahead and cut yourself a cubic meat of atmosphere and bring it in your house. Just want to let you know, okay? That's number one. Okay, so let's take a look at this. I did this a long time ago when this nonsense came out. Okay, the total distance of these power lines from that one photo he had over Lake Pontchartrain was 15.9 miles, right? I even back-checked it, did it myself. Per Soundly, his viewer height was between 35 and 50 feet. So let's say 45 or 40 feet. Now, the distance between each pylon is approximately 0.18 miles. And I counted, it was hard to count, but I got up to about 88 pylons in his shot. So, I'm sorry, I counted approximately 40 pylons. 88 was the total with that distance. So I counted 40 pylons in that the P900 shot. That's roughly 7 miles. And that's with significant curvature, right? So let's take a look at this. The Louisiana length, north to south, is 379 miles. Orleans Parish, they call counties down there parishes. Orleans Parish is 350 square miles, right? If these pics and video are true, then we must live on planet Orleans Parish. Now, come on, people. I mean, you need to look beyond, the narrative. Go ahead and look at these pictures. Look at what they're taking as observations. Don't get into the weeds. Step back a little bit. Look at the big picture, right? My word. It's like that Felix Baumgartner Planet New Mexico pic. So furthermore, according to the spinning ball narrative, every point along a tangent from your feet falls away from you in every direction at 8 inches per mile squared. So the horizon at 7 miles from 90 degrees through 0 to 270 degrees is 21.5 miles. So what they're saying is they see significant curvature on the Z-axis, which is at 7 miles, but along the X-axis, which is 21.5 miles, it's flat, no curvature, right? Are they on shrooms?
Yeah.
So to remain coherent, yeah, thank you. So to remain coherent,
No, they're on peyote.
Yeah, exactly. There's a lot of shrooms there.
To remain coherent with Soundly's Z-axis, the X-axis should look like, let me pull this up.
Well, we're on that, John. Nathan, I think I heard you commenting.
It's
you drove
Louisiana tube Earth.
Are you guys seeing this?
Yeah, exactly. There should be. I had this exact conversation earlier today with Dawn, and trying to explain to him that if you're looking along this line and you're seeing curvature, if you look along the other axis, you should see curvature. If it's a ball, it's a ball. If it's curved, it's curved. And in this instance, from every single direction from your feet. Therefore, if you're looking out exactly as this is depicted now, I like it, John, very good, you should see that curve from left to right. You never do. It's never there. It's ridiculous. Not that this is the kind of curve you should see. I think this is the point you're making, that's the level of curve based on his pylons and the curve that they're taking, right?
No, but that's a good red line, that is, because that's the best accentuator of the point that if we lived on Soundly's world, we would be on a basketball.
Right.
It's good to see it on that axis.
On a straw.
Is that applied the same curve, John?
Yes, I did. Yeah, I didn't do this, man. I picked this up. It had to be 2 days after he posted that his video.
Sweet, that is.
Let me tell you something. I don't know where I got this from, but I got it and I checked it out. I remember checking it out when I first got it, and I said, "Oh yeah, this is good to go." So I just stored it.
Well, we had Walt going across Lake Pontchartrain because he went for a flat Earth meetup. I know Nathan was watching it, and they went over the, the Soundly roller coaster with the bridges, and I actually sat there watching just somebody driving on a motorway, and I think Nathan was as guilty as me, just to experience those humps, those cheater's hump and liar's lump.
Imperceivable
in the
humps, you
realm
mean?
call them.
The ones that you don't even notice.
So that's a great exemplar, because you know when you see the slight bridges that occur on the Pontchartrain Bridge, and if you look at Soundly's models, they look, like you say, like a roller coaster, don't they? So to see his curvature explained on the x-axis it sums it up nicely, don't we? We do. Scroll it up? What's the phrase you use, bro?
I'm sorry.
We live on planet.
Oh, Planet Orleans Parish.
That'll do. I shall remind Walt of that. Planet Orleans Parish. Cheers.
It's just your local curvature.
Yeah, I'll do you.
So let's try this one. Let's check this one out.
Yeah, we've got just before you do, we've got Mark's avatar on now, which is the point Mark was trying to drum home about 3 or 4 shows ago. And we had Tim Osman on just saying, "What are you talking about? You guys are morons." And it's like they are so caught up in cognitive dissonance when it comes to this opposing axis.
Tim claims he's been researching flat Earth for three years, and yet he was surprised at my argument, as though it was new to him. He's just a liar.
Now, I think he's taking research in another context. Like,
no, he's lying.
He keeps on searching in the same direction. Research.
No, Owen, he's lying.
He's lying. How can he research it for 3 years and not come across the x-axis, z-axis argument? He's lying.
By only looking in one single way.
Ranty had a good example of that with the wind turbines.
Yeah, I take full credit.
My hero. He's brilliant.
I take full credit for that.
Yeah. I said, you know what? I still have those photos. Hold on. Maybe I'll pull them up. Give me a minute. So.
Oh, that's brilliant, because he's lost them. His hard drive went kaput and he lost those images.
I got them.
Cool. Well, that's handy.
Hold on a second. Let me just deal with this. And I'll go.
Sure. You're on. So,
it won't take that long. This is Soundly's pick, right? You guys seeing this?
Yeah.
Yeah, no problem. You guys see this? And apparently there's a curve here, right? Well, a similar picture. What do we see? And let me give the credit for this. I think this was Johnny Oops, whoever that is, that got this from. Right.
I just want to cite Nummy's words here. Soundly is the only guy that gets that level of that effect at Pontchartrain. Nobody else is getting it.
I don't want to be rude, Tony, but I've done it with Lego, bro.
Yeah, not on Pontchartrain, no.
No, on Pontchartrain. I've done it on my phone, right, with Lego, which we all know is straight, and I've created this straight image, and I've created the same curved image.
Yeah, with a fisheye lens. Yeah, but you used a fisheye. He's claiming
the point I'm making there is nothing to do with the
that sums it up.
Stuff that you guys have discussed at length. It's all about position of the camera, yeah, and where that camera position is with regards to the shape of the lens. And it's all about spending hours, and that's why you don't see Soundly giving streaming stuff. It's all about spending ages aligning the thing in such